I want to devote this whole lecture towards the mechanism of the nucleophilic substitution reactions in case of the square planar complexes. And we have already seen that if we are having some square planar complex of platinum of this type, in which this X here is what it is, the leaving ligand or the nucleophile, and we are adding some Y, that is the entering ligand or the nucleophile here. The nucleophilic substitution reaction will take place in a way that this X here will be replaced by this Y ligand, resulting in the formation of this as the final product, right? And this X will be moving out of the system such that the overall rate law equation for this type of nucleophilic substitution reaction in case of a square planar complex will be something like this here, right? So basically it will consist of two rate law terms. This will be the first part of the rate law, which is actually dependent upon the solvent, and this is the second part of the rate law, which is taking into account the concentration of the starting complex as well as that of the entering ligand, right? And moreover, we have also seen in our previous lecture that the K dash multiplied by the concentration of the solvent, which is actually present in very large excess and is also a constant thing. So the product of this K dash and S will come out to be constant, and we can write in place of this K dash and this S here, we can write it as the K1 value, right? So this was the overall rate law equation for such kind of nucleophilic substitution reaction. And we have also seen that both these parts of this rate law, I mean this one here as well as the other part, both are what they are associative in nature, right? Such that these two associative pathways, they may be summarized in this way, where you will see that the starting reactant molecule is undergoing a reaction with this Y entering ligand, resulting in the formation of this kind of complex here, in which this X is replaced by this Y ligand, right? And let us say this part here actually belongs to the K2 type of rate constant, which is this here, right? So we can say that from here to here is what it is, an associative type of pathway. It is this associative pathway here. And then we do have a solvent assisted pathway, which will be like this, in which first of all, instead of the reaction with Y, the solvent will be reacting with the starting complex molecule, and the rate constant there will be K1, right? Such that this X here, it will be replaced by the solvent molecules, resulting in the formation of this kind of solvento complex, and X will be moving out of the system, right? And after that, a fast reaction will take place, and that will be what it will be, the replacement of this solvent molecule with that of the ligand molecule, resulting in the formation of that same product here, right? So we are having this first associative pathway, which belongs to the K2 rate constant, which you can see here, I mean this pathway. And we do have a second pathway, which is this one here, resulting in the formation of this kind of solvento complex. And this is associated with the K1 type of rate constant, which is this product of the K dash as well as the concentration of the solvent. And I can write here, this is the K1 rate constant, and this is also an associative kind of pathway. Let me write here, this is the second pathway which is there in this same reaction, and that is also leading to the formation of a same product, but by this kind of route here, I mean this kind of route in going from here to here, resulting in the formation of this kind of product here, right? So this much we have already seen in our previous lectures, and now it is time to go into the details of the mechanism of the nucleophilic substitution in case of these square planar complexes, right? So for that, the mechanism part actually starts like this, in which you will see that if we are having some square planar complex in which we are having these four ligands, the X ligand which will be moving out of the system, the ligand T which is present trans to this X here, and two normal ligands, which is this L here as well as on this side, right? And now because it is a type of a square planar complex, so obviously the hybridization here will be what? It will be the dsp2, right? So if the central metal ion is having an electronic configuration in which these are the filled metal d electrons, so because the hybridization is dsp2, this means what? That one d orbital, one s orbital and two p orbitals are being involved in this hybridization, which I have shown here, right? So you can see here that this one d orbital is being involved in hybridization, and it is involved in bonding with any of the first ligand molecule here, let us say this first ligand, right? And after that this s orbital is being involved in hybridization as well, resulting in the formation of a bond with the second ligand, and let us say this is the second ligand here. In the same way, these two p orbitals are also involved in the formation of two bonds with the third and the fourth ligand. Let me say this is the third ligand and this is the fourth ligand here, right? So one d orbital, one s and these two p orbitals are involved in hybridization. So it is very clear from here that the last p orbital, I mean this pz here, is what? It is actually empty and it can accept electrons from the entering ligands. Okay, so the picture will be something like this, in which the metal atom having this empty pz orbital, I mean this orbital is what? It is this empty pz orbital we are talking about. What it can do is it can accept electrons from the entering new ligand, which you can see here. So because it will be donating electrons in this way to this empty pz orbital, it will be resulting in the formation of a bond in between the new ligand and the metal, such that now from this square planar geometry we will be having a geometry something like this. And you can easily recognize this is what? This is a square pyramidal type of geometry, in which now the new ligand will be present here on the top, right? So if I erase everything here except the geometries, we will see that from some 4 coordinated complex we are getting actually a 5 coordinated complex here, right? So this means what? That whatever substitution reaction in case of these square planar complexes we are talking about, these actually proceeds by an expansion of the coordination number, which you can see here, okay? Because the coordination number is increasing from 4 to 5 here, so it is what? It is an expansion of coordination. And moreover, we can say here that because this starting complex molecule here, it is associating with the new ligand molecule, that is why it is following what? It is following an associative type of mechanism. Let me write here, it will be an associative type of mechanism. And we have just seen on the previous slide that the rate for such a reaction will consist of 2 terms, the first term here and then the second term here. And we have also seen that the first term as well as the second term both will be having what? Both will be having an associative type of mechanism. Okay, so these all things will be more clear to you people when we will be dealing with the mechanism in detail right now. Okay, so you can see here this is the detailed mechanism for the nucleophilic substitution in this square planar complex here. So ultimately we will be having this kind of product in which you can see that the X ligand here has been replaced by this Y ligand here, right? So this is nothing, this is actually a nucleophilic substitution of this X ligand by Y ligand, and this is the mechanism here, right? So the first step is what? As we have seen on the previous slide, that the Y will be giving electrons to the empty pz orbitals of the metal here, resulting in the formation of a bond in this way. I mean this bond here in between the Y, that is the entering ligand, and the metal atom here, right? So that from a square planar complex we will be having what? We will now be having a square pyramidal type of geometry, in which the expansion of coordination number has been taken place from 4 on this side to 5 on this side. Okay, you can easily count here. It is 1, 2, 3, 4 and 5 ligands are now present here, right? So It is that same thing I have just told you, that the Y ligand is donating electrons to the empty pz orbitals for the formation of a new bond, that is this bond here, right? And after that, this square pyramidal geometry will rearrange itself into a new geometry, that is what? That is this trigonal bipyramidal type of geometry. And why this is happening? Because this geometry here is more stable, right? This is more stable as compared to that of the square pyramidal type of geometry, because in this case the different ligands here, they are present at an angle of, let me write here, they are present at an angle of 90 degrees here, right? So there are present relatively more repulsions here in this case as compared to the trigonal bipyramidal geometry, in which now the ligands are present at an angle of 120 degrees. So they are more away from each other. So obviously it will be having lower repulsions, right? So this is why it will be rearranging itself into a more stable type of geometry, that is the trigonal bipyramidal, in which the T ligand, Y ligand as well as the X ligand, they are present in the equatorial plane, which is this plane here actually, okay? This is the equatorial plane, this is the central metal ion, and after that the ligands, that is first L as well as second L, they are present axially. I mean, here is the first L and here is the second L, and you can see here that these two ligands are present trans to each other and are present axially in this geometry here, right? So this is the trigonal bipyramidal geometry. These are the axial positions, and these are these are the equatorial positions which are present in the equatorial plane here, right? What will happen next is that the X ligand, I mean this here, it will now be moving out of this equatorial plane. It will now be moving out of the equatorial plane in this way. So you can see that the X is now present like this here, such that the bond angle in between the T ligand, the metal as well as the Y ligand, it will open up. It will open up from this 120 degree to an angle of 180 degree, which you can see here. I mean this T here, M as well as Y. Now the bond angle is what it is, 180 degree, okay? So this TMY angle will simply open up from 120 degree to 180 degree, resulting in the formation of this kind of square pyramidal geometry. And finally, the elimination of this X ligand will take place from here. You can see here the X is moving out of the system, resulting in the formation of this kind of square planar as the final product molecule, right? So here is the mechanism of the nucleophilic substitution reaction in case of a square planar geometry, in which the X ligand is now substituted by the new Y ligand, undergoing different kinds of geometry transformations like I have shown here in this mechanism, okay? So after this mechanism, because you know that whatever mechanism I have talked about here is actually this part here, right? Is actually this part here. Let me go to that slide. It is actually this part here which we have just talked about in the mechanism, and now it is time to talk about the second part or the second pathway of the mechanism, which is also associative, right? So I can say here that this mechanism which we have just talked about, that is actually this part here, and it is an associative mechanism, and it is associated with this part of the rate law equation. I mean this rate law equation, okay? And now the second mechanism or the second pathway is also there, and it is this pathway here, in which the solvent will be playing its role. It will be this pathway, and that is also an associative type of pathway. And in this overall rate law equation, you can see that I am talking about now this part of the rate law equation. So this is actually linked with this pathway here, which is also associative in nature, okay? So now let us see what is this solvent assisted mechanism and how it is different from the normal type of mechanism, okay? So once again, this is the normal type of mechanism or the normal pathway which we have just discussed. And now we will be talking about the second pathway, which is this solvent assisted mechanism, solvent assisted mechanism, and the important thing here is what, that both are associative in nature, right? So once again, just have another look on the mechanism which we are just discussing, and I want to show here that the association of this complex here is taking place with the Y ligand, resulting in the expansion of the coordination from 4 to 5. Hence, it is an associated type of pathway, right? And now it is time to talk about the solvent-assisted mechanism, the second term of the rate law, and it is linked with this kind of mechanism here, in which the solvent will be playing an important role, right? So starting from the same square planar complex consisting of this ligand here, the second ligand, the ligand trans to the leaving ligand, and this is what, this is our leaving ligand X here, right? So before reacting with the Y or the entering nucleophile, before undergoing reaction with this Y here, first of all, this complex will be following a reaction with the solvent molecule, because it is a solvent assisted type of mechanism, right? So in the same way, the solvent will be giving electrons to the empty pz-orbitals of this metal ion, resulting in the formation of a bond in this way here, I mean this bond here, so that the geometry will change from a square planar complex to a square pyramidal type of geometry. And once again, the coordination number will also increase from 4 to 5 here on this side, right? So once again, this is also an associated type of pathway, and after that, the square pyramidal complex will now rearrange itself into a more stable type of trigonal bipyramidal geometry in the same way which we have just discussed, right? Now, the two ligands, that is the L ligand here as well as this L ligand, they will now be present axially, and the solvent T ligand as well as this X ligand, they will be present in the equatorial plane in this way, right? And after that, what will happen is that this X ligand will now be moving out of the equatorial plane in this way, such that the bond angle in between the solvent M metal as well as the T ligand here, it will open up from 120 degree to an angle of 180 degree, which you can just see here, right? So the angle is increasing and it is opening up from 120 degree to this 180 degree here, resulting in the formation of a square pyramidal type of geometry. And finally, the ligand X will be moving out of the system, resulting in the formation of this kind of square planar complex here, right? So in this solvent assisted mechanism, the main thing that is happening is what, that this X ligand here, it is first exchanged with this solvent molecule, so that now in place of this X here, we will be having this solvent molecule in this way, right? And now the second part will be what? It will be the reaction of this square planar complex with the Y ligand, such that now the solvent will now be replaced, it will now be replaced with the Y ligand here, okay? So now let us have a look that how this is going to happen. Before that, the mechanism from this part here to this part is what, it is actually an interaction with the solvent molecule, and it will be following the same kind of associated pathway. And from here, what will happen is, from here, this square planar complex will now be undergoing interaction with the Y ligand, that is the main entering nucleophilic ligand, right? And actually, we want, in place of this X here, we want actually the Y ligand. But before Y comes here, what is happening? S is replacing this X here, giving this type of square planar complex, to which now an interaction will start with the Y ligand, right? So the reaction goes like this, the mechanism goes like this. So once again, the Y ligand will come here, it will now be giving electrons to the empty pz metal orbitals, resulting in the formation of this kind of bond here. And this is what, this is the square pyramidal geometry. And you can see here that when we started with this mechanism, we were having solvent S here at the top of this square pyramidal geometry, and now because in place of this solvent here we are adding the Y ligand, so what is happening is that in place of this S we are now having this Y ligand here, right? And initially at the start of this mechanism, we were having this X here on this side, which was the leaving nucleophile or the ligand. And now in this case, we are having S here of the solvent molecule in place of X. And in the same way, X was moving out of the system. Now in the next steps here, what will happen is this S will be moving out of the system, right? So what will happen is that from this square pyramidal geometry, it will rearrange itself into a more stable trigonal bipyramidal geometry, so that we will be having these two ligands on the axial position, and the T ligand, Y ligand as well as S ligand will be present in the equatorial plane here, right? And after that, as usual, the S ligand, I mean this here, it is now moving out of the equatorial plane, which you can see here. This is the equatorial plane here, and S is moving out from here, which you can see here. It is now present in this way, such that the bond angle in between the T, M and Y, it will now open up from 120 degree to an angle of 180 degree here, right? And finally, the elimination of the solvent molecule from this square pyramidal geometry will result in the formation of this kind of square planar product, in which finally the X has been replaced by this Y new entering nucleophilic ligand here, right? And this was the motive of our nucleophilic reaction, that we want this X to be replaced by this Y ligand here, and that has been completed with two different kinds of mechanisms. The first, or the regular mechanism, that was associative in nature, and then we have seen that we do have another mechanism, which is the solvent assisted mechanism. But unlike the first mechanism, which contain a single associated type of step, the solvent assisted mechanism contains two associative steps. This is the first one here, in which the solvent is associating in this way with the complex molecule, and here is the second associative step, in which the Y is associating with the rest of the complex molecule in this way here, right? So this is the main difference between the regular normal mechanism, which contains a single associative step, and the solvent assisted mechanism, which contain two associative steps. And the last thing which I want to add here is that both the mechanisms are taking place simultaneously in the conversion of this starting molecule or the starting complex into this kind of final product molecule, in which the X has been replaced by the Y ligand here, right? So this is all about this lecture here, in which we have seen that how the nucleophilic substitution reactions will take place in some square planar complex, and we have also seen that what kind of mechanisms will be there and what is meant by the associative type of pathways. So this is it. Thank you so much.